when we factor with binomials, we're going to look for our greatest common factor, like we typically do with all of our factoring problems. But everything's going to be about a perfect square. And when we're referring to a perfect square, we're talking about a number that you can take the square root of, and your answer is a whole number. So, for example, 25 is a perfect square, because the square root of 25 is exactly 5. 5 times 5 is 25. Square root of 20? No. I mean, we can break it down, but it doesn't give us a whole number. So binomials have to have perfect squares, and that's just part of your math fact recognition of, do I have a perfect square or not? So let's go into some of these. Let's hit a basic one, and that's someone like this. We just kind of talked about 25, so that's why I figured it'd be a good one to start with. Now, the things we want to watch for is, first of all, there is a subtraction sign, and there needs to be a subtraction sign here. Because every time we factor a binomial, the only way we can do it is if we've got a perfect square, and we do with our 25, x minus 5 and x plus 5. Things that we want to watch for here. We're still getting our x squared. If we FOIL this out, x times x is x squared. We're still getting our negative 5 times our positive 5, which is our negative 25. And what we want to notice here is, when we check those inner terms, we've got a negative 5x and a positive 5x. Opposites, so they're gone. It's not there anymore. And that's only way a binomial can be factored. We need the subtraction sign so we get different signs. And then this way, when we combine them, they go ahead and they take out that middle term or that x term we look at. So yeah, it's just about noting perfect squares that we're looking at. So yeah, that's it. X minus 9, x plus 9. Now it doesn't matter if you say x plus 9 and x minus 9. Remember, it's a factor. Factor are numbers that we multiply together. So 2 times 4 is going to be the same answer as if we do 4 times 2. So let's just throw something at you here. Let you write one down for yourself. Let's go after x squared minus, and then let's just go 16. All right, put it down. Yeah, x minus 4 and x plus 4. Now, what we don't want to do is be like, oh, hey, I see another perfect square, 4s. I can factor again. X minus 4. No, it needs to be an x squared. So because it's just an x, yeah, no, we're not dealing with any factoring that goes along with it. So that's all it really takes. Now, the things we do want to watch for is your greatest common factor that shows up. So let's say we go 2x squared, all right, plus, oops, let's not do plus, we won't do that yet, maybe we'll bring it out here in a second, minus, all right, and then 72. All right, so it is a binomial, but the number one rule of factoring is always greatest common factor. And they're both even numbers, so that means we can divide them both by 2. So we'll pull that 2 out. 2 times what is x squared? No, x squared. 2 times what is 72? Remember, instead of trying with your math x, realize that dividing by a 2 is just cutting in half. So half of 72? Yeah, that's a 36. That's there. And now we can go, oh, I see you. Oh, there it is. It's a binomial. I've got an x squared. I got a minus sign, and we've got a perfect square here. So the 2 comes along for the ride, and we got an x minus 6, and we've got an x plus 6. So that's really the only way we can kind of get sneaky with your binomials, is if we end up simply bringing out a greatest common factor. And that's why you always want to start there. Let's see. Now, there's other things, but again, I'm just a big fan of, hey, greatest common factor, and then let's see if we can write them. If we see someone like this, can't do it. All right, we can't do it because it's addition sign. So not factorable. It's kind of like a fraction when someone says, hey, why don't you simplify 1/2 for me? Well, we can't. All right, there's nothing more that we can divide by. It's already in simplest form. That's what we talk about with our factoring. Factor this for me, please. I can't. It can't be factored anymore. All right, so let's give you one more. All right, let's throw GCF in there, and we'll go ahead and throw your factoring of a binomial in there as well. Let's go 5x squared, and let's go minus, and No. Let's see here. Let's give you something pretty nice that's there. Let's go. No. Hey, hold on a second. Okay, I got it. Sorry. I paused there because I didn't want to. Here we go. A little sneaky here. See if you can do it. Pause it. All right. So, greatest common factor. Did you take a 5 out? All right. 5 times what is x squared? Well, 5 times x squared is. 5 times what is 5? Well, it's a 1. Now, thing here is 1 a perfect square? And it is. The square root of 1 is 1. So we can factor that 1 as x minus 1 and x plus 1. So really the places where we see mistakes happen is just some of our computation. As long as you know to look for it, you're going to miss it sometimes. I mean, it's just like anything. It's sometimes we're just going to glance over it and we're just not going to see it. We lose something in the house and we're like, I can't find it. Someone walks in and they're like, it's on the counter. It's right here. Well, that's what happens to our factoring. We're like, I just missed it. I didn't see it. So that's your factoring of your binomials. Greatest common factor, and then make sure you've got yourself a perfect square.